Hello dear students of plus 2 medical, non-medical and respected teachers. Today I am going to discuss another important topic which is Zener diode and its use as voltage regulator or stabilizer from chapter of semiconductors plus 2 class. First of all, what is Zener diode? So Zener diode is nothing but heavily doped PN junction diode. It is heavily doped PN junction diode which operates only in the reverse bias, which operates only under the reverse bias conditions in the breakdown region. So, and this Zener diode can be used as a voltage stabilizer or you can say a regulator. Now, when this PN junction is forward biased, we know that current increases rapidly with the increase of forward voltage. So, as Zener diode is nothing but PN junction diode, but is heavily doped. So, when forward bias is applied to Zener diode, it behaves just like ordinary PN junction diode. So, current increases rapidly with the increase of voltage beyond a certain value called potential barrier. So, it offers less resistance to the flow of current when it is forward biased. So, this is the graph for Zener diode also. So, in the forward bias condition, Zener diode behaves similar to ordinary PN junction diode. But when it is reverse biased, as Zener diode is heavily doped, so this depletion region is very thin due to heavy doping of majority carriers, holes of P section and electrons of N section. And as we know that when PN junction is forward bias, majority carriers they move opposite from the junction. So it offers infinite resistance to the flow of current. So you can say practically it doesn't conduct. So when we increase the reverse voltage, so reverse current is very small. It is of the order of microampere only. And it is only due to minority carriers which cross the junction. So when we go on increasing the reverse voltage, a stage comes beyond at the particular voltage, reverse voltage known as Zener voltage, current rises abruptly. Current rises suddenly. There is sharp increase in diode current, reverse current you can say. And when we increase the voltage further, then there is no change in current. That is, current becomes independent of reverse voltage beyond a particular value known as Zener breakdown voltage Vz. Why this happens? Because when voltage is increased, reverse voltage is increased, then temperature of the sample also increases. Temperature of sample increases and a stage comes at a particular Zener voltage when all the covalent bonds are break down. As a result, large number of electrons and holes are produced. So current rises abruptly. This phenomenon is known as Zener breakdown. And the particular voltage at which this occurs is known as Zener breakdown voltage. And this property of the Zener diode makes it used as a voltage regulator or voltage stabilizer, because beyond the Zener voltage, current becomes independent of voltage. Now, this is reverse bias diagram of PN junction. Now, as PN junction is heavily doped in case of Zener diode, So depletion region is very, very thin. As a result, electric field is very, very large across the junction, which is E is equal to minus d by dx, because dx is very, very small. So electric field is of the order of 5 into 10 raised to 6 volt per meter. So very high electric field is set up. And due to this very high electric field, temperature rises and all the covalent bonds are broken at a particular voltage. So this is how current rises abruptly in case of Zener diode. So this Zener diode can be used as a voltage stabilizer or regulator. How? What is the circuit for voltage stabilizer? So make the connection as shown in figure. Here we have resistance R, Zener diode and load resistance connected in parallel, and this is the input circuit, and output, constant output is taken across the. How this Zener diode acts as voltage stabilizer? So when fluctuating DC, input voltage is applied to the input circuit. When current grows, current starts flowing, voltage difference, potential difference takes place across R, then some current goes through the load and some current goes through the Zener diode. Zener diode should be reverse biased, always should be reverse biased. The two conditions for Zener diode to work as voltage stabilizer: number one, Zener diode must be reverse biased. Number two, the Zener voltage, the applied voltage must be greater than the Zener voltage, Zener breakdown voltage. Then and only then it will work as a voltage stabilizer. These are the two conditions. When current increases, beyond Zener voltage, what will happen? Current increases beyond the Zener voltage, current increases in the circuit, the voltage drop across R will increase. And beyond Zener voltage, this Zener diode resistance becomes almost negligible. So excess current passes through the Zener diode, and current through load remain the same. That's why we get constant output across the load. So again I repeat, when current input fluctuating voltage increases beyond the Zener voltage, potential difference across R increases. As a result, this PN junction, Zener diode becomes, resistance of PN junction, Zener diode becomes negligible. And beyond Zener voltage, most of current passes through the Zener diode, and current through load remain the same. So we get constant output across the load. Similarly, when voltage decreases, potential difference across R decreases, but current across the load remain the same. As a result, we always get constant output across the load. So Zener diode plays an important role to make the voltage across RL constant. So this is how Zener diode acts as a voltage regulator or voltage stabilizer. So this is one of the most important applications of Zener diode, and we again repeat, for Zener diode to work, Zener diode must be reverse biased, and number two, voltage applied must be greater than Zener breakdown voltage. And this is all about Zener diode and its characteristics. Then I will discuss in the next video, I will discuss photodiode, LED and characteristics of PNP and PN transistor. Till then, good luck. Stay tuned for next video. All the best. Be happy. Good luck.